Write a function is solvable maze that takes in a maze and returns true if maze is solvable and false otherwise. So here the maze that goes into our function is actually this maze, and it is a list of strings, and each string contains a bunch of symbols. So here S means start, and this is where our player will start from. X means the end, which is also the objective of our maze. The dash means a road which our player can exist on, and a hash means a wall which our player cannot exist on. So here let's talk about some rules of this maze. So we always assume that S will be on the top left of our maze, and S can only move one step at a time, and only in 4 directions: up, down, left, or right. And next, S can only land on dash characters and not the hash, because the hash is a wall. And if S reaches X, we win. So here a maze is solvable if S can reach X eventually. And here the challenge will be to write your function in one line of Python code. So do pause this video and take a while to give this a try before taking a look at the answer. So here, as I always say, before we can write our code in one line, we must always be able to write our code in multiple lines of code. And here I have a multiple line solution. However, whatever we have here cannot really be condensed into a list comprehension or whatnot. So we need to solve this in multiple lines in an alternative way. So let's actually carry off this first. So let's define is solvable, and here we write our function body. So similarly, from here we need to search its neighbors, which is this one and this one, and eventually we need to search this and this and this and then this and all the way until we reach X. And one way that we can do this in fewer lines of code is to use recursion. So here in each function call, we only take care of one search. So let's say we have a maze, and next we have scene is equals to empty set. And next, we need to pass in both the row and column. So let's use R as row is equals to 0, and C as column is equals to 0. So next, whatever we find will be stored inside scene. So first thing I'm going to do is this. So scene.update R, C, and I'm also going to store whatever symbol is in row and column here. So let's add a list here. So here, if you're not familiar with the update method of a set, the update essentially adds whatever we have here into scene. So let's actually return scene for now. And if we run this, we are going to get S and 0, 0. So here, both our coordinate 0, 0 and the symbol that is on our coordinate S is actually inside our scene now. So next, let's search for our valid neighbors. So for DR and DC in up, down, left, right. So given our current row and column, up means -1, 0, down means 1, 0, left means 0, -1, and right means 0, 1. And here I use DR and DC because delta row and delta column. So new row, which is NR, is equals to DR plus R. So this is our new row, and new column NC is equals to DC plus C. So here let's print new row and new column. So let's run this, and here we are going to get the 4 neighbors. So once again, -1, 0, and 0, -1 are actually not valid coordinates as they are outside of our maze. So we need to write some code in order to ignore this. So next, if NR is more than or equals to 0, and NC is more than or equals to 0, and NR is less than the length of maze, and NC is less than the length of maze NR. So here, this entire condition will check that NC and NR are within the confines of our maze and it is not out of bounds in any way. And next, we also need to check for this. So if NR, NC is not in scene, because if we have already seen it, we do not want to see it again. So and next, let's check the symbol. So maze NR and C is in either X or dash. So here, if our neighbor NR and NC fulfills all of these conditions, we can call is solvable again recursively. So is solvable, and maze, scene is equals to scene because we are reusing the same scene, and then R is equals to NR and C is equals to NC. And at the end, let's return scene and let's see what happens. So I'm going to do this. So here we have both coordinates as well as symbols. So here the symbols are here. And here we know that this is actually solvable because X is somewhere within scene. However, if we change this to a hash, we should expect that X won't be in this scene. And so now we only have S and dash. So here, let's do this. X in scene. And if we run this again, and if we make this solvable, we should get a true now. So as of now, we have a multi-line working function that will tell us whether our maze is actually solvable or not. And notice that this is much shorter than whatever stuff we had just now. So now that we have a multi-line working function, we can try to shorten this into one line of code. And here, this is going to be super long, so let's actually replace some of our variable names first. So M is big M, and S is Z. So now this will be S. So next, we replace this with big M, and this too. So scene is now big S, so this is now M, S, and this is S, and this is going to be S. So let's run this again to check whether anything goes wrong. So if we do this, it should be a false now, and if we open this, this should be a true. Okay, so now we can further condense this into one line of code. So any NRs will become dr plus r. So this becomes dr plus r, this becomes dr plus r, this becomes dr plus r, and this also becomes dr plus r, and this becomes dr plus r. And similarly, any NCs become dc plus c. So this becomes dc plus c, and this also becomes dc plus c, and so on. So dc plus c. So this way we can get rid of this too. This one is dr plus r. And next, we can actually combine this nested if block into one. So and let's get rid of this, and let's do this, and let's check if this still works properly. So this is still true, and if we block this, it should give us a false. And here it still works. So next, let's condense this into a list comprehension. So we take this and we put it at the start here, and we take this giant S condition and we put it at the back here, and we put this in square brackets to change it into a list comprehension. And so if I run this, I'm gonna get false still, and if I open this somehow, I should get true. And there we have it, true. So right now this still works. And now the last step will be to combine them all together using semicolons. So semicolon, and if I run this, I should still get true, and if I do this, I should still get false. And here we have it. We have managed to solve this function in one line of Python code. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.